Good afternoon, everybody. Welcome to class today. Thank you for joining me. Thank you for watching, whether you're watching live or you're watching the recording. I appreciate you watching. Thank you for tuning in today. So this afternoon, the big thing I really want us to do is I just want us to kind of take some time and work through some demonstration. Right, basically what I'd like to do is take some of the key things that you would want to do in order to complete the lab assignments for this module and do some demonstration of them so that we can have a better understanding of what we need to be doing for our labs. Right, so I'm just going to be writing some code. Some of it will be more for the simplified grading lab. Some of it will be more for the solving the age-old issue lab. But either way, right, it's going to give us some options in terms of ways that we could approach these problems. Right, so let's start out by writing our shebang statement, hashbang /usr /bin/env python 3. And let's also go ahead and add in our main gate. If __ name is main. Like so. And just for the time being, I'm going to put a pass statement underneath there. I will revisit that when we are ready to call a function and remove that pass statement. That pass statement just gives me something that I can put there that will allow my program to run with the main gate in place. It basically just says ignore this, right? So that's what that's for. So ideally, right, we want to have our list, which another name for a list is an array. One of the things from the video last week that we kind of looked at is this idea that with a variable is a container that we can put one piece of data into, take one piece of data out of and use it. Whereas with an array, what we end up with is a container of containers. And each of these containers inside of this list or array, we can use like a singular variable, put data into it, take data out of it, and we just use the index location of the container 0, 1, 2, 3, so on and so forth, to be able to address specific pieces of data inside of our list. So let's say, for example, we have a list, and this list is going to be, say, a grocery list, right? So we might have a variable name, groceries, and set it equal to a list of groceries. So apples, bananas, pears, grapes, right? We're just getting fruit on our trip to the grocery store today. But this is our list. Right? And so if we wanted to print out the item so if we wanted to print out bananas, right, we would print groceries at index location 1. And that will bring us bananas out on our output. Right, remember in programming, we start counting at 0, so the index location of apples here would be 0, bananas is 1, pears is 2, grapes is 3. Right, so one of the things that we might want to do is we might want to add to this list, right, which is something that is going to be beneficial to us, is the ability to take a list and add to it. And so we can do that by using the append function. So one of the ways that I could just do this, right, is I could take groceries and append just whatever the user inputs. Right, and if I were to do that and then print out groceries, we would be able to see the updated list with the new thing in it. Right, so it's telling me to enter a grocery. That's based on this input we see here inside our append function. And so if I enter a grocery here, let's say we are getting kiwis, then we see it adds it to the end of our list. Right, the append function in Python is going to append a new item to the end of our list. So that would be what we would use to add something to our list. Right, so normally if I were to do this, right, I would use my composition rules and I would break things down to where I have a function that is going to be designed to add the grocery. Now this function would take in some sort of parameter. Let's call it A for array, even though it's Python, so it's a list. And so it's going to take in some sort of an array. And the existing array, we're essentially going to return the value of A.append input enter new item. Right, so ideally what I would want to do here is use this function, and I could use it in some sort of loop, right? Some sort of indefinite loop. Right, if you remember back to when we were talking about loops, we have definite loops, we have indefinite loops. If I have a definite loop, what I'm doing is I would have a certain number of steps that I need to travel before I get to the end of my loop. If I have an indefinite loop, then what's going to happen is I'm going to have to determine where the end of my loop is with some other condition. Right, so typically what we might do here is make an interface function. And that interface might bring in the array. Right? And so we could say something like, take a variable user input, set it equal to input of enter desired action, and just give some choices for our desired actions. Right? Maybe A to add, X to stop. Right? Is where we'll start here. So we can say something like while true, if user input is A, then we will run our add grocery function with the value of our array parameter in there. Elif our user input is X, we will break. And at the end of the day, either way, we are going to return A as the function, but as the list back out of this function. Right, so this interface function is basically just a function that I can take and encompass all of my actions in. Right, so I'm going to use this one function to call other functions, so I can keep the number of things that these other functions are doing down to a minimum. Make it a little bit cleaner. Right, and then I'm always going to return A back out, because A is going to be ultimately what I do for my or ultimately what I'm going to need to use to return a random thing, right? Because that's what we're going to do. We're going to give ourselves a random choice from this function to be able to do, right? So if we look at, say, the age-old issue lab, we're told to create a list with at least 5 different choices. In this case, we have a list with 4 choices. I want to be able to display the choices, which is going to be a function that I would add here as well. And then give the user the option to add a choice or get a selection from the already derived option. So what I would basically want to do here is, in my while true, I would want to maybe nest an enhanced for loop here and say something like for item in A, print item. Now we might even want to say, print currently in list, just to give ourselves a bit of a heading there. And maybe after that last item in A, before we do the other condition here, we would want to just print an empty line, like so. Right, so now it's going to go through, it's going to iterate through, print all the items in the list. Then it's going to allow me to choose to add a list item or break. If I add a list item, I will input the A key on my keyboard to add a list item. At which case it will add the list item and then iterate the while loop again, print the new list, ask me and we'd actually want this input. This input is out of space, right? So we would want to actually move this to be inside of our while loop, like here, right, to actually make that work a little bit better. So that's where we would want it to go. And so now I can print the list. It's going to print the list every time. I can add something to the list. And it's going to return A, which is our array after all things are done. And we've added everything to the list that we wanted to add. So in this case, right, what we could do is we could print the results of the interface function using groceries as our parameter array here. And this will give us the ability to add some, right? So it tells us what's currently in list. We say A to add. Should be running add grocery A. There it goes. It just took it a second to update there. Replit must be having a few problems here. We'll add kiwis. Replit must be having some trouble this afternoon. But this does work. Maybe instead of using the application, I would want to use the website. So let me pull up the website really quickly. This is the desktop application, which is, to my knowledge, just a PWA or progressive web application. So it should be working the exact same way. And if we actually pull it up here, it actually shows us where we are currently after we added kiwis from the other window, which is kind of neat. All right, so A to add a new item. Maybe we want bacon. And then it shows us it adds bacon to the list. A to add another item. Eggs. It shows us it adds eggs to the list. And ultimately, right, we can hit X to stop. And at this point, it's just going to print the entire list. So we can see the entire list at that point. has kiwi, bacon, and eggs included in it. Right, so when we want to just get the random choice, we can use the Python random library. And we can import that with an alias as R. Right, so I can create a new function. Call it select random. Bring in some array parameter A. Right, and really all I would want to do here is just return A dot, or actually it's R dot choice A. And the choice function here, which is a part of the random class, just takes an existing list and picks a random choice from it. So in this instance, what I would want to do is maybe reassign groceries with the value that we get from running interface with groceries as the argument. And then finally, we would print select random with groceries. And that would give us a random choice. And so this is a lot of what it would take to solve the solving the age-old issue lab. It is fairly trivial to actually solve from here and make it meet all of the requirements that are in the lab assignment. But I can write an X or an A here, enter a new item, let's say kiwis, A for eggs, A and bacon, A ham. I'm trying to enter several things here, so maybe we get something that wasn't on our original list. And we see when we do that, we hit X to stop it, it stops it, and we get salad mix as the random selection back out of it. Now, if we were to do that again, just to see it work again, maybe to get something that is not at the end of the list, we see we get apples from the first of the list, right? It's just picking me a random choice. And so that's what it's going to do, right? So I could have this starting list that we see here in line 28 be as long or as short as I want it to be. I can add as many elements to that list as I want to add to it. And when I'm finally ready to get a choice, I can hit X to break my loop. And it's going to return to me a random choice selected from my list. Right, which is pretty useful. And so we could basically take this and use it as the foundation of that solving the age-old issue lab. Some other interesting things that we could do, right? If we could take some of this stuff and add it to some other stuff here, like for example, I'm going to take and make a new file here, and I'm going to call it numbers.py, and I'm just going to work in this other file here for a moment, and I'm going to hashbang /usr/bin/env python 3, and I'm just going to want to be able to do some stuff with some numbers. Right, so we can kind of take some of the stuff that we learned from that previous example, right, to figure out how we put things into a list from an input, right? Like the only difference is if we were using numbers, we would have to do typecasting the way that we've done for things in the past, because remember that input does bring in a string. So if I wanted to do something like find the highest thing in a list, well, we can just do a brief proof of concept, right? So we can call this proof list, And inside of this proof list, we could just put some number. Right, so square brackets 4, comma 25, comma 43, comma 12, comma 1, comma 78, comma 98, comma 5. Right, and so if I were to say print max proof list, that is going to print for me the biggest number in my list. Right, so let's run this in the shell since it's a different file. So let's run python numbers.py, and we see we get 98. Right, if I wanted the min, I would print min proof list. Right, so that's going to get me the smallest number from the proof list. So it should give me 1 as my second output value here. So my first output value should be 98. But it is still in line with what we have here on line 5. So 98 and 1 should be my expected outcome. And that's exactly what I get. Another thing that I could do here is I could get the range. Right? We already know the max and the min values, so I could just subtract the min from the max. Max proof list minus min proof list. And that's going to give me that value. Another option, if I wanted to get the average of all of these numbers, the easiest way for me to do it, probably without using any other libraries, would be to use the sum function. Right? So if I wanted to, right, I could take and I could print the sum of the entire list. Right, so if we see these examples played out here, we can see 98, 1, 97, 266. So if I take the sum of all the values in the list and divide it by the length of the list, that's going to give me the average of all the numbers in this particular list. Which makes this super simple in terms of getting to where you would need to go for the simplifying grades assignment that is in the lab. Right? You'd basically use some of the stuff that we used in our first example to add the things to the list. Remember that in this instance, since we're working with numbers instead of strings, we would want to do typecasting. We would want to append the integer value of the input instead of just the string value, right? But both of these examples combined together gives us what we need. So if we take these examples and combine them together with the video from last week where I discussed lists in more detail with you all, your lab assignments for this module should be rather trivial. And so I think that's all that we really need to do for today. So I'm going to go ahead and stop here. If you're watching the recording of this and you have any questions, please send me an email or a Teams message and let me know. That's all that I have for you for today. Thank you for watching. We'll see you next time.